Hello, everyone, and welcome. I'm excited to have you here today. Our presentation is titled Understanding Robots. Throughout this session, we will explore the fascinating world of robotics, starting from basic definitions and moving into real-world applications. We'll discover what makes robots unique, look at their advantages and limitations, and discuss the challenges that are shaping their future. So, let's get started and dive into this exciting topic together. Today, we're going to go through what we'll cover in this presentation. First, we'll start with robot fundamentals, where we'll understand what robots are and explore their key characteristics. Then, we'll look at the advantages and disadvantages of using robots, comparing them to human workers across different scenarios. Next, we'll examine robots versus machines, helping us distinguish between various types of automated systems. Finally, we'll discuss future challenges, focusing on the obstacles and hurdles in implementing and developing robotics technology. Throughout this talk, I want you to see how these topics connect to the big picture of robotics' role in our world and its potential for the future. So, what exactly is a robot? Well, the word robot actually comes from the Czech word robota, which means forced labor. It first appeared in the 1920 play RUR, where it was used to describe mass-produced workers that didn't have their own thoughts or creativity. A robot today is an autonomous machine, meaning it can operate on its own without human control. It can sense its environment through sensors, process information, and make decisions based on that data. Then, it performs actions in the real world, whether that's moving, manipulating objects, or even completing complex tasks. This brings us to the field of robotics, which is all about designing and creating these machines and systems. Robots come in many shapes and sizes. Some are tiny, like the size of a coin, while others are as big as a car. They can do everything from making pancakes in a kitchen to exploring the surface of Mars. Understanding what robots are and how they work is fundamental to grasping the broader theme of automation and technological innovation. Robots are constantly evolving and becoming more capable, shaping the way we live and work. Let's take a closer look at the key characteristics that define robots. First, their mechanical construction is tailored for their specific environments. For example, the Mars 2020 rover has titanium wheels designed to handle the harsh terrain of the Martian surface. This shows how their physical structure is built for durability and function in extreme conditions. Next, we have electrical components. These include power systems and control circuits that allow robots to operate. Most robots rely on batteries or electricity to power their actions, making them self-sufficient and capable of functioning over extended periods. Then there's computer programming. This is essentially the brain behind the robot's actions. The code directs when and how they perform tasks, giving them a sort of intelligence and the ability to make decisions based on the data they collect. Speaking of data, sensors are another critical feature. Robots use sensors like LiDAR, cameras, radar, wheel encoders, and GPS, similar to human senses, to detect their surroundings. These sensors help robots understand their environment and respond accordingly. Finally, movement and energy sources are essential. Robots navigate using wheels, legs, or thrusters, depending on their design. They are also self-sufficient, powered by batteries, solar energy, or electricity, allowing them to operate independently in various settings. All these characteristics work together to make robots versatile, intelligent, and capable of performing complex tasks across different environments. Let's explore some of the key advantages of using robots in various industries. First, cost-effectiveness is a major benefit. Robots can work continuously without needing breaks, which significantly increases output. This helps recover costs more quickly and even boosts overall earnings. Next, the increased productivity is impressive. Robots excel at performing repetitive tasks more efficiently than humans and without getting tired, leading to a dramatic rise in production levels. When it comes to quality, robots help ensure better quality assurance by minimizing human error. They follow precise manufacturing and inspection standards, which results in consistent, high-quality products. Speaking of consistency, Robots can execute the same tasks with identical accuracy over long periods, maintaining uniformity in production. They are also invaluable in dangerous environments, such as nuclear plants, deep oceans, or battlefields, where human safety could be at risk. Finally, using robots can positively impact workforce motivation. By taking over dull, repetitive tasks, robots free up employees to focus on more skilled, engaging work, fostering a better workplace atmosphere and encouraging skill development. Overall, these advantages highlight how robots are transforming industries and improving efficiency, safety, and employee satisfaction. Now, while robots offer many benefits, there are also some important disadvantages to consider. One of the biggest concerns is potential job losses. Since robots can perform tasks faster and with greater accuracy, they might replace human workers in certain industries, which raises questions about employment and economic impact. Another challenge is the high investment costs. Setting up robotic systems involves significant expenses, not just for the robots themselves, but also for programming, installation, ongoing maintenance, parts, and ensuring a continuous power supply. These costs can be a barrier for many organizations. Then there's the need for skilled personnel. Operating and maintaining these robots requires specialized training, which adds to operational expenses. It's not just about buying the robots. You also need trained staff to keep everything running smoothly. Overdependence on technology is another issue. If a system failure occurs, it can halt entire production lines, and recovering from such failures can be both costly and time-consuming. This reliance can sometimes make processes more fragile. Safety is also a critical concern. Industrial robots can pose injury risks to workers if proper safety measures aren't in place. That's why safety zones and collaborative robots, designed to work safely alongside humans, are so important to mitigate these dangers. Finally, robots have limited intelligence. They can't improvise, reason, or feel emotions. They simply follow programmed instructions, which means they lack the creativity and adaptability that humans bring to complex tasks. So, while robots are transforming industries, understanding these disadvantages helps us better prepare for and manage their integration into the workplace. Let's clarify the difference between robots, computers, and machines. First, is a robot just a computer? No, it's not. A robot is a machine, but it's not just a computer. The computer inside a robot gives it intelligence and the ability to perform tasks. Now, when we compare robots to computers, a key point is that computers alone can't change or navigate their environment. They operate based on instructions, but don't physically interact with the world. Robots, on the other hand, do. They physically interact with their surroundings. Think of assembly line robots welding car parts. To help understand this better, think of your body as a robot. Your brain is like the computer. It plans what you need to do. Your arms are like the robot's limbs. They carry out those plans. Moving on to robots versus machines. Remember, all robots are machines, but not all machines are robots. Robots have specific features that set them apart. When it comes to control, machines usually need humans to operate or control them externally. Robots, however, only need initial instructions to start working. They can carry out tasks on their own after that. Regarding sensory input, robots are equipped with cameras and sensors. This is how they see, sense, and understand their environment, giving them a kind of machine vision. Machines without sensors lack this capability. Lastly, the software inside robots tends to be more sophisticated, allowing for a higher degree of autonomy. In contrast, simple machinery might only run basic software without adaptive or intelligent features. All of these distinctions highlight how robots are more advanced and capable of independent operation compared to traditional machines or simple computers, fitting into the broader theme of technological evolution. Did you know that even young inventors are making impressive strides in robotics? For instance, a 13-year-old boy from Chennai named Pratik has designed a robot called Rafi. This robot is quite special because it can actually detect emotions and recognize when someone is sad. It's fascinating to see how technology is advancing to understand human feelings better. What's really interesting is how Raffi responds to emotional cues. If someone scolds it, it goes silent, almost like it's upset or embarrassed. And if you apologize, it will respond again, showing a kind of emotional reaction. This illustrates how robots can be programmed to simulate emotional responses, even if they don't truly feel emotions like humans do. It's important to understand that while robots don't naturally share human emotions, programmers can give them preset emotional responses. For example, a robot might show signs of fear if its sensors detect a temperature above 100 degrees. These programmed responses help robots interact more naturally with us, making them more useful and relatable. So, in the bigger picture, this highlights how the line between human emotions and robotic responses is becoming more nuanced, all driven by clever programming. It's a great example of how technology is evolving to bridge the gap between machines and human feelings, which ties right into our overall theme of exploring the possibilities and limits of robot emotions. Now, let's take a look at some of the key challenges we face in implementing robotics effectively. One major issue is the development of new materials and manufacturing techniques. Traditional gears and motors, while reliable, tend to make robots inflexible and prone to malfunction. To create more versatile and energy-efficient robots, we need innovative materials and production methods. Another challenge is energy sources. Developing advanced batteries and alternative energy solutions is crucial for powering these next-generation robots reliably and for longer periods. Without efficient energy, even the most sophisticated robots can fall short. Navigation and environment mapping also present significant hurdles. Robots often struggle to navigate obstacles or adapt quickly when their environment changes. Even small alterations can require them to relearn, which causes delays or, worse, accidents. Then there's the issue of job displacement. As robots become more capable of performing repetitive tasks efficiently, there's a real concern about replacing human workers across various industries. Balancing technological progress with societal impact is an ongoing challenge. Security and privacy are also critical. The data collected by robots, videos, photos, location information, is vulnerable to hacking. Plus, questions around ownership and ethical use of this data remain largely unresolved. Creating robots with multi-purpose functionality adds another layer of complexity. Most current robots excel at specific, repetitive tasks, but designing machines that can perform multiple functions effectively is still a tough nut to crack. Finally, social integration is an area where we face both technical and ethical challenges. Developing robots that can genuinely display empathy and social behaviors and can seamlessly integrate into human social structures is essential for their acceptance and usefulness in everyday life. All these challenges highlight how complex and multifaceted the journey toward advanced robotics truly is. So to wrap things up, let's go over the key takeaways from today's presentation. First, what exactly is a robot? Well, a robot is an autonomous machine that can sense its environment, make decisions using computation, and then perform actions in the real world. It's not just a simple machine. It's designed to operate on its own, adapting to different situations. Now, when we talk about the core components of a robot, we're referring to several essential parts. These include the mechanical structure that gives it shape, electrical components to power and control it, and computer programming that guides its behavior. Sensors are vital because they allow the robot to perceive its surroundings, and movement capability enables it to interact physically. Of course, all of this needs energy sources, like batteries, to keep everything running smoothly. Next, let's clarify the distinction. Robots are more than just machines. They have a level of intelligence derived from computers. Unlike simple machines, they feature autonomous control, sensory input, and complex software that allows them to make decisions on their own. This intelligence is what sets them apart and makes them truly robots in the modern sense. Finally, a quick look at the broader field of robotics. It's a fascinating study area focused on creating these intelligent machines and automation systems. While robots offer incredible benefits, like increased productivity, better quality, and improved safety, they also face challenges. These include issues with materials, advancing their intelligence, security concerns, and how they integrate socially. The future of robotics depends on overcoming these obstacles, but we also need to consider ethical questions, like job displacement and data privacy, that come with this rapid technological growth. Connecting all of this to our overall theme, it's clear that robotics is not just about machines. It's about innovation, responsibility, and shaping the future.